Hi everyone, this is Zakir and this is the 10th video in our module functions. Today we will be discussing about logarithmic functions. In the previous video, we discussed about exponential functions. A logarithmic function is the inverse of an exponential function. So the inverse of the exponential function fx equals a to the power x can be written as f inverse x equals log of x to the base a. This can also be written as gx equals log of x to the base a, where x is a positive real number and a is greater than 0, and also a cannot be equal to 1. One important base of an exponential function is an irrational number symbolized by e, whose value to 5 decimal places is 2.71828. This symbol is called the natural base, and the function fx equals e to the power x is called the natural exponential function. So, if y equals e to the power x, we can say that x equals log of y to the base e. In short, this can also be written as x equals ln y. Ln y is called the natural logarithmic function. So now, if we are given the coordinates of an exponential function, how are we supposed to sketch the graph of its inverse, that is, the logarithmic function? Let's take the coordinates of the exponential function that we sketched in the previous video and plot it on a table. So these are the values. The exponential function y equals 2x. So when x equals minus 1, y equals 0.5. When x equals 0, y equals 1. Similarly, when x equals 1 and 2, y is equal to 2 and 4 respectively. So now, to sketch the logarithmic function, we take the y coordinates, the y values of the exponential function, and switch it for the x coordinates of the logarithmic function. So here, y equals 2 to the power x is the exponential function. The logarithmic function is y equals log of x to the base 2. So now that we have the x values from the previous table, 0.5, 1, 2 and 4. Now we have to find the y values. When we substitute the x values into this equation, we get minus 1, 0, 1 and 2. Notice that x and y values have been switched here from the previous table. The x values 0.5, 1, 2 and 4 are the y values of the exponential function. Similarly, the y values of the logarithmic function are the x values of the exponential function. Now when we sketch this on a graph, this is the graph that we obtain for the logarithmic function. We can see that the logarithmic function is in fact a reflection of the exponential function about the axis y equals x. This is the axis and this is the reflection. Now for the tip of the day. The base of a logarithmic function can be changed using the following formulas. When you get the reciprocal of a logarithmic function, the base and the answer switch places. So log of b to the base a is equal to 1 over log of a to the base b. For example, log of 5 to the base 3 equals 1 over log of 3 to the base 5. So here we can see that the base has been changed from 3 to 5. To change to a base of your choice, we use this formula. Log of c to the base a equals log of c to the base b divided by log of a to the base b. For example, let's take log of 5 to the base 3. we can write it as log of 5 to the base 2 divided by log of 3 to the base 2. So here the base has been changed from 3 to 2. With that, we wrap up this video. Share this video to your friends or to anyone who will benefit from this video. If you have any questions, please ask us in the comments below. We are always ready to help you. Until then, take care.